All right, let's look at 7.8, number 23. We've got the limit as x goes to infinity of x squared plus 2x over e to the 3x minus 1. Both of these are nice continuous functions. If I plug in infinity, I'm going to get, is that positive infinity? Yeah, because it's positive infinity plus positive infinity. But what if I had a minus 2x up there? Does it change what it approaches? It'd be infinity minus infinity, which normally you say is indeterminate, but would I actually be able to figure out what that infinity minus infinity was if that was a minus sign? Yep. Which one's bigger as you get huge? The x squared explodes a lot faster than doubling it, right? So like if you take 100, if you double it, you only get 200. If you take 100 squared, you're gonna get 10,000. So this one approaches infinity faster. So even if there was a minus sign in between, that would still be a plus infinity, okay? Anyway, over e to the infinity is infinite. So it explodes. So this is infinity over infinity. So what are we gonna wanna do here? Continuous functions. We're gonna wanna use L'Hopital's, right? So this is gonna be equivalent to the limit as x approaches infinity. Take the derivative of top and bottom, so it's 2x plus 2. All over, what's the derivative of the bottom? Derivative of e to the x is e to the x, so it's e to the 3x times the derivative of the denominator, which is 3, right? And what do I get? I still get infinity over infinity, right? So what could I do? Do it again. So you use L'Hopital's again. So it's going to be the limit as x approaches infinity of top, I get 2, denominator, I get 3 times derivative of e to the 3x is e to the 3x times 3. So that's, anyway, that's 2/9. So we got the limit as x approaches infinity of 2/9 times 1 over e to the 3x. Now what can I do? I can let x go to infinity. And this ends up being 1 over infinity, right? So this is going to go to 0. No, what is it?
Yeah. So 1 over infinity.
Times. Yeah, I don't like it. Anyway, but it's 0, right? So 2/9 times 0 is 0. Fine. Is that what that's probably what the answer in the back of the book is, isn't it? It better be 0. If it says 2/9, it ain't right. So I'm going to change my problem. Huh? Number 23, 7, 8.
0.
It has 0.
Has 0.
So let's change the problem. Let's let x go to 0 from both sides. What do I get here now? This is a great problem. Oh, I know, you wanted one more. Anyway, 0 over 0. Could I use L'Hopital's again?
Yes.
Okay, so this is a totally different problem. But anyway, I'm going to solve it the same way. So L'Hopital's. So once again, limit as x approaches 0, 2x plus 2 over 3 to the 3x. And then I'm going to use L'Hopital's again, and I'm going to get limit as x approaches 0 from both sides of 2 over 9e to the 3x. And now I'm going to let x approach 0, and I get e to the 0, which is what? 1. So that ends up being 2/9. Okay? See, you got to pay attention. But that's just a different version of number 23. Okay? As I mentioned to everybody else, don't forget the theorem. E equals the limit as x approaches infinity of 1 plus 1 over x to the x power. So inside here, this is getting closer and closer to 1 from the top side, and the exponent is getting bigger and bigger and bigger. So really, it's a 1 to the infinity form, but that's what E is, because this ends up being 2.71828, etc., an irrational number that never ends, never repeats, which is E. We could rewrite this as the limit as t approaches 0 from the right of 1 plus t, because that gets closer to 1 from above, to the 1 over t, which approaches positive infinity. When you get 1 divided by a very tiny number, it explodes up. Same deal, either one of these is correct. So there are problems like number 6 from section 7.8, where we have to manipulate and use this definition to change it over and see that that limit is E. All right, thank you.